Okay, let's try and do a graphical analysis now. We know that the change in pressure across a slab of the atmosphere is proportional to minus the density of that slab. And we also worked out, by assuming things were an ideal gas with the same temperature, that the pressure is proportional to the density with a constant c that we worked out. So if we combine those two, we find that d pressure by d height, the rate of change of pressure, is equal to a minus p over our constant c times g, which is a very familiar equation. That's telling us that the rate of change of pressure with height is proportional to minus the pressure with a constant in front. That's exactly the equation we've seen before for radioactive decay, and in several other situations it's telling us the solution is going to be an exponential. But meanwhile, let's think about graphically how we do it. What this is telling us is the slope, the rate at which the pressure drops, will depend on the pressure. The pressure is going down, therefore the slope is going down. So we need a curve where we plot pressure or density, they're just proportional to each other, against the height, and it's going down. But as the pressure gets lower, the slope, the gradient, becomes less. So it's got to curve this way and flatten out. So that's what it's got to look like. Our previous estimate was simply assuming the density was the same everywhere, which would be equivalent to working out this height here by assuming the thing has the same slope at the beginning place. And that was about 10 kilometers. But in reality, as you get higher, the gradient will flatten out, and in principle the atmosphere will go on forever. In practice, by the time you're 1,000 kilometers up, the solar wind starts interfering and our physics goes out the window, and it's pretty tenuous long before you get there. But this is clearly what it's going to look like. Pressure drops off. It's dropped very substantially by the time you're at 10 kilometers, but it's still got a little tail that goes out to very large heights.